second that. I think I must have made a mistake. All right. Oh, I was putting 7 instead of 4. Sorry about that. Store that in list 2. Here we go now. And I have what I want. Okay. I'll do the same thing. Second, and then go to cumulative distribution function for 0.25. Store that in list 3. And then what I'll do is, if you check here now, you have your probabilities, and you can check that the cumulative probabilities, actually, if you add all the probabilities, end up with 1, so that makes sense. So anyway, just by looking at this, we can see that we say the mod is the largest value of x for which the probability distribution function has a maximum. If you look at this, we have maximum probability when x is equals to 1. So the mod of x is equals to 1. How about the median? We're looking for the smallest value, the value of x for which CDF is more than 0.5. So let's come back here. CDF is more, that will be 1 again. So the median of x is 1. So we can say that mod of x is equals to 1. B, median of x is equals to 1 as well. All right, number 4. So x follows binomial distribution with parameters 6 and 0.35. Find A, the mod of x, and then B, the median of x. So basically, A is the mod of x, B is the median of x. Let's find them. I'll use the calculator again. So what we need is to clear this list. Clear that. Clear that. Now x can take these values, but because 6 trials, I'll add 5 here and 6. Great. Now in list 1, I'll plug in the probability distribution function, the probabilities of this distribution, and then in list 3, I'll plug in cumulative probabilities. So let's start with the probabilities. So second, number of trials is 6. Success is 0.35. Leave that blank. Press enter. You have your probabilities. Now in list 3, I'll try again this time round. Hopefully it will work the way I tried the previous time. But I think I messed up by plugging a wrong number. So I have 6, 0.35. Leave that blank. And I have the probabilities. So once you have that, you can just inspect and find out what the mod is. And so let's start with the mod. The mod that will be the highest probability, which I think is 2. 2 is the mod, and the median is 2. So 2 and 2. Okay. So in C, they're asking us the probability that x is less than 2 lots of A, and A is 2, so probability is less than 4. Given that X is it's greater than B, which is 2 from our N B. So I can write this a conditional probability. So X is less than 4 and X is greater than 2 of probability X is greater than 2. And this is the same as, actually I can write it below here. Probability X is equal, I mean the intersection of that is 3. Given that this is a discrete random variable, keep that in mind. And here we have to write it in this form so that we can plug it in the calculator. All right, now if you plug that in your calculator, X is equals to 3. So here what we have to do is you have got there, there, okay, we have 6, 0.35, and the X value is 3. You'll get that value, and then in the denominator we have 1 minus that's a cumulative probability, remember. Number of trials is 6, success is 0.35, and 2. All right, so it's 0.2355 divided by 0.3529. So if we divide those values, let's see. So this is the same as 0.2355 divided by 0.3529. And you'll end up with a 0.667. Good. Number 5. Let's. Oh, I was just reading number 4. Number 5. In the mass production of light bulbs, the probability that one bulb is defective is 1%. Bulbs are selected. Let me just highlight a few things here. So probability that one bulb is defective is 1%. That's very important. Bulbs are selected at random and put in packs of 8. Selected at random and put in packs of 8. Actually, alternatively, what is more important here is they are put in packs of 8. From there, we can actually write down our parameters. One is the probability of success is 0.01. And because these bulbs are put in packs of 8, then we can say that the number of trials, if you are going to check these bulbs, that the number of trials n will be equal to 8. Anyway, let's move on and just read to get an idea of what's going on in this question. If a pack is selected at random, what is the probability that it will contain at least one defective bulb? So let's first of all start by writing our distribution. So we can say that X follows a binomial distribution with parameters 8 and 0.01. And we can start with A1. What is the probability that it will contain at least one defective bulb? So at least one defective bulb means one or more, which will be equal to 1 minus probability no defective bulb. Um, so if you plug this in your calculator, so 1 minus 0 defective bulb, that will be at least 1. Remember, these are discrete random variables. Anyway, so if you go on your calculator, you can do just 1 minus and plug that in PDF. So 8 trials, probability of success is 0.01. Our X value is 0. So, and then you'll get your answer. So 1 minus that gives us that, which will be 0.077. Part 2, we want probability of, if I can just scroll down, great. So probability X is less than or equal to 2. That will be equal to, and of course you can just plug this in your calculator. I'll show you again. Once you get the idea, in the next examples, I'll assume that you can just do this by yourself. Anyway, second, look for that binomial distribution, cumulative probabilities, because you're looking for X is less than or equal to 2. That will be X is equals to 0 plus X is equals to 1 plus X is equals to 2. So those are cumulative probabilities. Anyway, so number of trials A, probability of success is 0.01. Cumulative probabilities up to X is equals to 2. And then you'll get your answer. I'll write these to 4 significant figures. So, which will be 0.9999. All right. So B, given that a pack selected at random contains at least one defective bulb, okay, this is condition probability. What is the probability that it contains exactly 2 defective bulbs? So probability it contains 2 defective bulbs, given that we have that. All right, given that it contains at least one defective bulb. So what we have to do here is to work out this. Again, this is conditional probability, like I said. So let's make this clear. All right, so if you plug this, not really plugging, but if you inspect the numerator, the intersection of X equals to 2 and X equals to is greater than or equal to 1 is probability X. Probability X is equals to 2. That's the intersection. Remember, these are discrete random variables, not cumulative. Good. So once you have that, all that we have to do is to work out the numerator separately on your calculator. I'm assuming you can do that by yourself. That and that. Get those answers, and then just plug in there, and you should be able to get these values. You get 0.00264 over 0.077, which will be 0.0342. All right. It's the same way I mean, the numerator you plug in using PDF, and then the denominator using CDF, and then you should be able to get that. Okay, I'll move on to number 6. An apple is picked from a large number of apples. So an apple is picked from a large number of apples in a container. The probability that an apple is bad is 0.05. A sample of 15 apples is selected at random. Find the expected number of bad apples. Now remember what I said initially. I say that if X follows binomial distribution with parameters n and p, then the expected value is equal to n multiplied by p. So basically what you're going to do here is they're asking us to find the expected number of bad apples. And in this problem here, suppose X represents the number of bad apples. So basically X follows our binomial distribution with the parameters 15 apples, so 15 trials, and probability that's a bad apple is 0.05. So what we can say is the expected value of X, just using the formula that I have here, the expected value of X will be 15 multiplied by 0.05, because n here is 15 and p is 0.05. Now if you multiply those, you should be able to get what the probability, the expected value of X is, which is 0.75. All right, I'll move on to number 7. A random variable R follows a binomial distribution with parameters n and p with mean 2 and variance 1.5. All right, I'm just going to highlight a few things here. So the mean is 2, the variance is 5, and what they are saying here is X follows binomial distribution with those parameters. But they're telling us that the mean is 2. So the expected value, and you know what the formula for expected value is? The expected value is NP. And by the way, the variance binomial distribution, I showed you that previously when I was introducing this topic. Variance is n multiplied by p multiplied by q. All right, so, and q here is a complement of p. So what I'm going to do here is I'll just write here 1 minus p, if that makes sense, to reduce the number of variables that we have. So what they're saying here is this is equal to 2 and this is equal to 1.5. So basically, first equation, np is equals to 2, np multiplied by 1 minus p is equals to 1.5. What you can do here is to find the values of n and p, let's divide these two equations. So what you're going to do here is we can write this n p multiplied by 1 minus p divided by np will be equal to 1.5 divided by 2. And you'll notice that these two guys will cancel. So I'll end up with 1 minus p will be equal to 1.5 divided by 2 will be 0.75, which means that p is actually 0.25. So we have what p is. Now to find q, we'll just use this equation here. So and to find p, we'll just to find n, not p. To find n, we shall divide 2 by p, because we know what p is. So that will be equal to 2 divided by 0.25, which is equal to 8. So n is equals to 8 and p is equal to 0.25.